Today. Hi, I'm Phil. Today we are going to Hello, I'm Phil. Today we are going to conduct the ball and ramp experiment. In this experiment, we are going to find the relationship between the acceleration of an object and the angle of the ramp. We will also determine the relationship between the mass of the object and its acceleration.
Hello, I am Mark and I will be assisting Phil in this experiment. To calculate our data, we will use two equations. The first, speed equals distance divided by time, and second, the acceleration equals the change in velocity of the object, all divided by the total time. And here we go.
In the first part of this experiment, we are going to change the ramp angle to find what will happen to the acceleration. We will find it at the angles of 15 degrees, 30 degrees, 45 degrees, 60 degrees, and 75 degrees. We will use a golf ball for this experiment, which has a mass of 0.045 kilograms.
Hello again. In the second half of our experiment, we will use several balls, all with different masses. The first ball we use is a tennis ball, which has a mass of 0.070 kilograms. The second ball has a mass of 0.145 kilograms, and that is a baseball. And the third ball is a basketball, and that has a mass of 0.620 kilograms. While doing these experiments, the ramp will be at a constant angle of 30 degrees. Back to you, Phil.
In this experiment, I think there will be a direct relationship in both the cases of acceleration versus ramp angles and the acceleration versus mass. I believe the accelerations will increase as the angle and mass increase.
But I think differently. I predict there will be a direct relationship between the acceleration and the ramp angle. As one increases, the other will as well. But I also predict that the mass of the object will indirectly relate with its acceleration. I also think that as the mass of the ball increases, the acceleration will also decrease.
It's time to experiment.
Let's see who's right.
We're back now. We're going to start our first experiment with a little constant angle of 15 degrees. We're going to do 3 trials to make sure that we can try and get rid of all experimental error. Okay, Mark, you ready?
I am, Phil, but before we do this, I'm going to make sure that the ball is very steady, and I'm going to use a ruler to hold it in place, so that when I let go, there will be less human error than if I just dropped it.
Okay, and just a reminder, this is a length of 1.22 meters, this ramp. So here we go, Mark, you ready?
I am, Phil.
Okay, trial 1, here we go.
In 3, 2, 1.
Look at that, 1.29 seconds.
Just a little bit off on our original time.
Okay. Here we go. 3,
1 more time?
Yep. No, 2 more times. 3, 2, 1. That's going to be 1.25 seconds for all you keeping track at home.
And the third and final time.
3, 2, 1. 1.21 seconds.
Very nice. Hello. Now we are doing our second
trial of.
You said fucking A. You gotta cut that. For our next trial, we increase the angle of the ramp to 30 degrees. Setting my watch to 0. Phil, do the honors.
3, 2, 1.
A solid 0.77.
3, 2, 1.
0.79. A little slower.
In 3, 2, and 1.
0.75. There you go.
For our third trial on experiment 1, we will use 45 degrees. Mark, you ready?
I am, Phil.
Here we go. In 3, 2, 1. 0.51.
Second.
Yep. 3, 2, and 1. 0.51 seconds again. Here we go. And 3, 2, and 1. 0.60 seconds for the final trial. Thank you.
Nice timing, Phil. Fourth trial.
60
at
degrees.
60 degrees. Thank you, Phil.
You're always welcome.
Are you ready?
Yes. 3, 2, and 1.
0.38 seconds.
That's a pretty good time, I think.
Pretty fast.
In 3, 2, and 1.
0.51. A little slower.
In 3, 2, and 1.
0.42.
Yes. Thank you.
999. 1,000.
I think that's good enough for today. Oh, we're back. We're gonna. Alright, do this last trial. I think I had a good enough workout for today. Phil, you ready?
Yeah, I'm ready.
Alright, last trial at 75 degrees.
In 3, 2, and 1. 0.25.
That's fast. Speedy golf ball.
3, 2, 1. 0.28.
A little slower.
3, 2, 1. 0.22. We're good to go.
Are you going?
For our second experiment, we will use 4 different balls at a constant ramp angle to see how the weight of the ball affects its time and acceleration. First, we will do the golf ball.
We're getting a pen right now, so we can.
Safety first. Ready? In 3, 2, 1. The golf ball came in at 0.77 seconds. Second, we will do the tennis ball. Mark has really good hands, as you can see.
I tried.
We will start in 3,
Nice and steady.
2, and 1. That came in at 0.73 seconds. Third, we will use the baseball.
Yeah, I caught it.
We'll go in 3, 2, and 1. 0.65 seconds,
And the big ball.
otherwise known as the basketball. Can you move this back a little bit? If
I
we
can,
have it,
I can.
if we have it forward, it will result in some experimental error because it will have a head start versus the other ones. We were just showing you this to remind you of what may happen while conducting this experiment. We're going to start it in 3, 2, and 1. Wow, I think the basketball came in with the fastest time, 0.60 seconds. As you remember, in the first experiment, we changed the angles of the ramp. Using the equation v equals x over t, we used the 1.22 meters of the ramp divided by the time that we found to get the speed. Using that speed, we were able to find the acceleration using the equation acceleration equals change in velocity over time. As you can see, we have our accelerations here and our ramp angles on this side. As the ramp angle went up, the acceleration went up, resulting in a direct relationship. However, if the ramp angle would be over 90 degrees, the acceleration would stay at a constant 9.81 meters per second.
Squared. Hello. In our second experiment, we changed the mass of the balls. First, we went from the lightest golf ball, then heavier tennis, and keep progressing heavier and heavier with the baseball and the basketball. As you can see with our gathered data, as our masses increased, so did our acceleration. Therefore, resulting in a direct relationship between mass and acceleration.
I predicted that both of the relationships would be direct.
I did not. I was wrong.
As always, I win.
But will he win in a duel?